Hi everybody, this is Mr. Rancourt. We're going to take some real quick notes on balanced and unbalanced forces, and I know that I've been kind of drilling this into your head, and that's all for good reason. I thought this was a great visual to kind of sum things up. So all we're going to do is just going to discuss as we kind of fill in the blank here real quick. So let's get started, okay? So the purpose of today is to be able to determine if the forces acting on an object are balanced or unbalanced. And you're going to do a quiz towards the end of the class. But I want to make sure that you understand it one last time and that you have a good reference sheet to help you. All right, so when I want to know if the forces on an object are balanced or unbalanced, what I need to do is do some mathematics. And by that I mean I need to calculate the net force. And so the net force, sometimes you'll hear it called the resultant force, is the sum of all forces acting on an object. This net force is the sum of all forces, and I'm going to add an S there real quick, acting on an object. So if you look at this little example right here, you'll see that the cake is being pulled down towards the table with gravity with a force of 2 newtons. And the tabletop is pushing up on the cake with the same amount of force, with 2 newtons. And remember, we've talked about that when these arrows are in opposition, either left or right or down and up, in order to calculate the net force, you subtract. So if I take 2 minus 2, I'm going to get 0. Okay? So in the blank here, all I want you to do is fill in 2n minus 2n equals 0 newtons. And that's how you calculate the net force of that particular scenario. So let's do the right side. Actually, let's go down first, and then we'll do the right side and the left side. So like we just talked about, when the forces are moving in opposite directions, we need to subtract. Okay? So for instance, you'll see that this person right here is pushing down with 3 newtons, and this person, obviously a larger person, is pushing down with 6 newtons. So you're going to know, well, first of all, you know that this person is pushing with more force, so it's going to be unbalanced. In other words, these hands are going to move. So all we're going to do literally is just do this. 6 newtons minus 3 newtons equals 3 newtons. And that's how you calculate the net force. And right here, all I want you to do is just write 3n, so that makes sense. Okay? And what that means is this, that this person is going to push to the left or down their way to the left, yeah, with a force of 3 newtons, stronger than the other person. Okay? Now, a different scenario is this. What if we have forces acting together? Well, if they're moving in the same direction, in other words, the arrows are either pointing all to the right, like in this scenario, or all to the left, or all up, or all down, then we're going to take these two numbers and we're going to add them together. Yeah, so 6 newtons plus 8 newtons equals 14 newtons. That means there's a combined force of these two animals pulling that cart with 14 newtons. And literally that's all I need you to write right here is 14 newtons. Okay? And forces always occur in pairs. Always occur in pairs. So either they're in pairs like this working together, or they're in pairs meaning that they work in opposition. But you'll always find two forces acting on an object at all times. Okay? Let's start at the top right hand corner. You don't really need to know this for this class, but just so that you don't think I forgot to mention something, just so you know, 1 Newton is equal to 1 kilogram times a meter per second squared. Again, I'm not going to spend any time on that, but just so you know, just fill it in, but you don't need to remember that. All right. Unbalanced forces can be, so write unbalanced. Unbalanced forces can be either all the same direction all the same direction, or, and actually that should be in the same direction, not all. Sorry, I can't read my notes. In the same direction, or they can be in opposite directions. Like that. Okay. Again, we just figured that out over here. Yeah, they can be either in the same directions down here, or they can be in opposite directions. When forces are unbalanced, there is a change. There is a change in motion. And the forces are not equal. When forces are unbalanced, there is a change in motion. The forces are not equal. Well, that makes sense, because if you look over here, we know that this guy's going to move, right? So they're unbalanced. There's movement. Yeah, there's a change in motion. Yes. And the forces are not equal. And so just think as unequal being unbalanced, or unbalanced meaning it's, and we're going to add this in. Unbalanced means moving. Okay. Well, conversely or oppositely, let's go to this other side. So when forces are balanced, there is either no motion or there is constant motion. And I'm going to explain that because that's a little different than what I've told you, but I think it'll make sense here in just a second. But get this down. When forces are balanced, there is either no motion or constant motion. All right. Balanced forces do not cause change in motion. The forces are equal. E-Q-U-A-L. Sorry, I can't spell. That's a Q. All right, so when the forces are balanced, there is either no motion or there is constant motion. Okay. So here's a real quick guide as to what to remember when it comes to balanced and unbalanced. And when you get to your test, if you're not quite sure if you should add or subtract, I want you to refer back to this. I'll allow you to pull this out so that you can use this kind of as your cheat sheet. It seems as we go through this in class that most of you get it. So this may not be helpful because you already know what it is. But if it is helpful for some of you, great. Thanks.